Sequences and graphs. Take 6. Using the nth term of a sequence. Objectives. Use the nth term to generate terms of a sequence and find the nth term of the arithmetic sequence. Why do we learn these? Many things around us follow a pattern. Knowing how a pattern continues can help us. For example, where planets are going to be in the night sky, or perhaps how COVID-19 is going to be over the next few months, whether it's going to go up or down. The nth term of a sequence tells you how to work out the term at any position, and it's also called the general term of the sequence. It's nothing to be frightened of. A lot of people worry about it. Oh, I can't do this, I can't do this, it's algebra. No, it's not. It's just a position in a sequence. If n is 1, that is the first term. If n is 100, it is the 100th term. It is as simple as that. A worked example. The general term of a sequence is n plus 12. Write down the first 5 terms. So all you're doing is changing that n for 1, 2, 3, 4 and 5. So when n is 1, you get 1 add 12, 13. When n is 2, you get 2 add 12, 14. When n is 3, you get 3 add 12, 15, and so on. If I want to work out the value of the 12th term, I let n equals 12. So I'd have 12 add 12, which is 24. The general term of a sequence is 4n. Write down the first 5 terms and then work out the 15th term. Okay, the first 5 terms. For the first term, that's n is 1. 1 times 4 is 4. When n is 2, the second term, 2 times 4 is 8. 3 times 4, 12. 4 times 4, 16. 5 times 4 is 20. So the 15th term will be 15 times 4, which is 60. That's all it is. Pause the video and have a go at these questions. Restart the video when you have done them. Find the general term of each sequence. So for the first one, 3, 6, 9, 12, 15. I see that goes up in threes. So the first term is 3, the second term is 6, third term is 9, and so on. That is your 3 times table, so I write down 3n. The second one, 2, 4, 6, 8, 10. This is going up in 2s, and I notice it's the 2 times table, 2n. C is the 10 times table, or 10n, and D is the 11 times table, or 11n. It's not too bad. So far everything is nicey, but what do we do when things are not quite so clear cut? Consider 1, 3, 5, 7, 9. The 5th term is 9. What is the 10th term? Oh, that's easy. 5 times 2 is 10, so 9 times 2 is 18, I hear you say. But it's not. It's 19. So what has gone wrong, and how do we work things out? As a general rule, you cannot double the 5th term to get the 10th term. So the sequence 1, 3, 5, 7, 9, what does it go up in? It goes up in 2s. I've written 2s as 2s, hope you don't mind that. That means in general term will have something to do with 2n because it's going up in 2s. Alright, so if we let n equals 1, then we get 2n, 2 1s are 2. If we let n equals 2, then 2n's, 2 2's are 4. If we let n equals 3, then 2n is 6, and so on. So using the 2n bit, we get 2, 4, 6. But the sequence goes 1, 3, 5. So if I compare 2, 4, 6 with 1, 3, 5, we see that we have to subtract 1 each time to make it correct. So if I have 2, take away 1, I get 1. 4 take away 1 is 3, 6 take away 1 is 5, and so on. That means the general, or the nth term, is going to be 2n minus 1. So our original question on the last sheet was the 10th term. So here, 2n minus 1 means 2 times 10, because it's the 10th term, which is 20. And the rule says take away 1. 20 take away 1 is 19. That's how it works. Okay. Pause the video and have a go at these. Restart it when you have done them. Try them in the same manner I have done the last one. Okay, so the first one was 3, 8, 13, 18, 23. The sequence goes up in fives. So when n is 1, 1, 5 is 5, 2 fives are 10, 3 fives are 15, and so on. So we get a sequence 5, 10, 15, which we are comparing with 3, 8, 13. To get the 3, 8, 13 from 5, 10, 15, we have to subtract 2. So the nth term will be the 5n, which is what it goes up in, take away 2, which is what we have to do to get our sequences the same. Similarly, 8, 14, 20, 26 goes up in sixes. So comparing the 6, 12, 18 that we get from 6n with the 8, 14, 20 means we have to add 2. So the nth term is 6n plus 2. Okay, your turn in a moment. Summary so far: 1, 3, 5, 7, 9. The nth term is 2n minus 1. 3, 8, 13, and so on. The nth term is 5n minus 2, and the bottom one you can see. Can you see a quick way of getting the nth term? Oh, I can, but can you? Pause it, have a go. Okay, I'll use the last one as an example. Can you see a quick way of getting 6n plus 2 from 8, 14, 20, 26? Well, the number in front of the n, that's that number there, is what the sequence goes up in. Here it is 6. If I take the sequence backwards one term from the start, so the start is 8, and I'm going to take it backwards, I know it's going up in sixes. Alright, so if I take it backwards 6 from 8, I get 2. So here is my quick way of doing it. The number in front of the n is what the sequence goes up in. The number on the end is take it backwards one term from the start. Okay, let's just check we know what we're doing with this. We could do it as a two-stage number machine. So if we look at the sequence 11, 19, 27, 35, it goes up in 8s. So I'm going to write 8 in there as best I can do it with a mouse. And then if I take it backwards from the 11, take it backwards 8, I get 3. So 3 goes into there. And that now gives me 8n plus 3. So that's there. So let's check it's correct. If n is 1, that is 8 times 1 plus 3, which is 11. Well, that works. N is 2 gives 8 times 2, which is 16, plus 3, which is 19. So that works. If n is 5, which is the top of the bit I've got at the minute, 8 times 5 is 40, as 3 is 43. That works. So we conclude it does. Alright, I've given you a quick way of doing this as well now. So, your turn. Pause the video and have a go at these questions. Restart it when you have done them. So, summary very quickly. First sequence goes up in threes. Backwards from the start gives minus 1, because 2 take away 3 is minus 1. Nth term, 3n minus 1. Second sequence, starting here, 2, 6, 10. It's going up in fours. And backwards from the first term, 2 from take away 4 is negative 2. So what we have is 4n minus 2. And the third sequence starts with 2, 7, 12, etc. It's going up in fives. Backwards 5 from 2 gives minus 3. So the nth term is 5n minus 3. Of course, it wouldn't be me if I didn't do something difficult. So pause the video and have a go at these three. Be careful, because there's a pitfall if you're not careful. So, first term, 5, 7, 9, goes up in 2's, backwards from 5 goes 3, so the rule is 2n plus 3. 19, 17, 15. It goes down in 2's, but the rule says I've got to go up. So I'm going down, which means I'm going in negatives. So it goes up in minus 2's or negative 2's. So backwards from 19 is the opposite now, so I have to add 2 to 19 to get 21. So your rule now is 21 take away 2n, or if you prefer minus 2n, add 21. This sequence here starts with 20, goes down 18, 16, etc. So it's going up in negative 2's, backwards from 20 gives 22, and my nth term is 22 take away 2n. Right, so here we go. A couple of general reasoning questions, see if you can do these. Pause the video, have a go at them. General sequence of a term of a sequence is 10n. Is 35 a term in the sequence? Well, I can't have 10n being 35 because I would have to have n is 3.5, and you can't have term number 3.5, you either have 3 or 4, so no, it's not a multiple. Which term number has value 60? I put 60 equal to 10n. 60 divided by 10 is 6, so it's the sixth term. Which term will be the first one larger than 105? 105 divided by 10 is 10.5, so the first term bigger than 10.5 is clearly the 11th. The general term of a sequence is 5n minus 3. Which term number is 22, 47, and 112? The method is to make an equation. So you've got your 5n minus 3 is equal to 22. So to solve that, I have to add 3 to both sides, giving me 5n is 25, and then divide both sides by 5 to give me n equals 5. So it's the fifth term. So on a similar method for B, it's the 10th term, and for C, it's the 23rd term. Okay, it's your turn. No help, no answers. Pause the video, have a go at them, email your answers to your maths teacher, restart the video when you have done them. Be careful with the last one, I've been particularly nasty with that. Well, that's about it. A little bit of exploration. How many windows do you need for a row of 100 beach huts? Look back at the maths you've learned in this lesson and how you can use it to answer the question. Reflect. After this lesson, Karen says, I can work out any number in a sequence using a general term, and Fiona says, I can tell whether a number will be part of a sequence using the general term. So when are these statements correct? Anyway, a bit more on sequences in the next lesson, which will also involve graphs.